So thanks for coming out. We're going to skip intros because I think we've got 25 minutes and a lot of stuff to cover. So some of you know who we are, I think. And if you don't, go look online, you'll find out. So this is Tracing Adversaries, Detecting Attacks with ETW. There's been another awesome ETW. Well, let's not say this one's awesome yet, but there was another. It was awesome. ETW talk this morning. So if you want more depth than what we're going to provide in here, you might check out Zach Brown's talk once it gets released. So I'm going to try and get through slides as quickly as possible so we can get to more interesting things, the real meat of the talk. So Matt and I started working on this, and I'll just say up front, Matt's done like 95% of the work on this. So
Dave is very modest.
No. Anyway, we started out with this fundamental question, are there on-box tools that can help us discover advanced adversary techniques? And the answer is ETW is one of those things, or we wouldn't be here talking about ETW.
And one of the things that I wanted to tackle once I focused down on ETW is, two really big things. The first one is, how can I make ETW easy to orchestrate? Because out of the box, it's not necessarily very friendly for your average user. And then two, how can I use my background in incident response and forensics to provide some type of out-of-the-box capability that Dave and I found to be fairly useful, but then also lay the groundwork for others to take that research and then move it forward. So we're not going to cover a ton of the terminology, but there are just a couple key things that are important to understand when you talk about ETW. Again, Zach this morning covered all of these in greater detail than what we will, but just four key pieces of terminology you need to know. The first one is the provider. And this is just the supplier of the information. So the provider can be things from the kernel, from the operating system, or from things like layer 7 applications or services. Then there are things that are sessions, and sessions are just the collection of provider data. And so really a session can be made up of a single provider or multiple providers, and we'll talk about that a little bit more later. But all of these are then managed by the controller, which then basically just starts and stops these different sessions. And then the consumer, which is ultimately us, which then takes either live memory streams of these events or reads them from files, and then ultimately does something with them. And to illustrate this better than I ever can with words, this is what it kind of looks like in a visual image. So starting here with the ETW provider, your events are fed up into this end memory buffer that uses the session that's made by the controller, that's ultimately fed down into either an event log format, which is ultimately what we're using in an ETL file, or you can process the events in real time, which does have some advantages. Then there's this thing called the kernel session. And so the kernel session is pretty powerful in that it actually gives you events directly from the Windows kernel. So there are other providers that have the word kernel in them that is a little bit misleading because they're actually not from the kernel. This one is, but it also has some nuances and caveats when you want to interact with them. The first one is it needs to be controlled slightly differently. So I found that I cannot control application layer providers and the kernel provider in the same session. It requires two different sessions and two different buffer controls. These guys are nodding at me, so I feel like I'm actually making sense. And in older versions of Windows, you can only have a single session to the kernel provider. So if you have multiple tools, let's say things like Process Explorer, and you try to set some flags, you end up stomping on Process Explorer, or it will start up and then stomp on you. So in later versions of Windows, you can have multiple instances of these sessions, which makes things a lot easier. And then there's filtering. So there's a number of different ways to filter, but you really need to be focused on how to reduce your data set down into what's impactful for what you need to look at. What we're going to talk about today is not really scalable at an enterprise scope, but we are still using filtering. So we use both keyword filtering, which allows you to focus down on just groups of events that are like or similar in nature, or on event ID filtering, which allows you to do just arrays of event IDs to capture only those things, or to disable only those things. In the tool that Zach talked about earlier, they actually have message layer filtering, where you can filter out specific strings that gives you another layer of the ability to aggregate down some of the data. And so then ultimately, this is the tool that we're releasing kind of to go along with ETW. I talked about the two different purposes of the tool. The first one to allow for the orchestration and discovery of different providers. We'll kind of go into the numbers of providers that are available, but there's a ton. And then the second is to provide you an out-of-the-box forensic capability to go ahead and start investigating forensic collection with ETW. So imagine like a dynamic analysis for with ETW. And so ultimately, it all boils down into 6 providers. Those are the ones that we identified. It's by no means comprehensive of all the ones that are out there that provide you good data. But realistically, these are the 6 that we identified as important and the information that we're collecting.
This is the most bang for the buck, I think, out of the ones that we've looked at, which is barely scratched the surface, really.
But there are definitely some limitations. Some of the ones I've already mentioned about. So like, this is absolutely drinking from not 1 fire hose, but 6 fire hoses at once. And in the 3-minute video that Dave's about to show you, we generated about 150 meg of ETL files, which then is really slow to process. So I took an easy route, I'll say, and I used get when event for all the processing of ETL files, except for the kernel session, which is a pain. But it's pretty slow to actually parse through the files. And then it actually goes through and aggregates into PowerShell objects, which is pretty cool. And because of this, it's not out of the box enterprise scalable. Please, no one's going to do this, but don't do it anyway. No one's going to go back, fork this, and push it out to your enterprise and turn on. Please don't do that. It's really designed for data discovery, like I said, dynamic analysis, and then identifying what should I then go out and target that I can actually make enterprise scalable. Again, we're really just scratching the surface with what we're about to show you and what you can do with ETW. And there's hundreds of untouched providers out there, at different layers of what they provide. So one of the good examples I like to talk about is there's an IIS provider that can pump out all the IIS logs to you. So if you're interested in capturing things that may be attacking your web applications, you could look at the IIS provider, for example. And we'll show you how you can start interacting and playing with different ETW providers strictly with PowerShell now.
So one practical application of this tool is if you've got a piece of malware or some attack scenario, you want to see what kind of evidence might be surfaced in ETW. This is a good approach. And so that's essentially what this video is going to be that I'm about to show. So we'll walk through this a little bit. Everybody in here familiar with Empire? Somewhat? Okay. So Empire is think of it as an attack framework, PowerShell-based command and control type thing. So this is the start screen here. You can see we've got no agents currently reporting. And we're going to be using a Windows 10 box, fully patched for all of this. So initially, we're logged in to this account, norm no admin. This is a user with no admin privileges. And just to verify that, I'm going to run the whoami/all command. And you can see I'm not an admin on the box. I want to become an admin. So I know this is, apologize for people in the back, watch the video when it comes out, but down here at the bottom of the screen, just using certutil to download a PowerShell script from a Google shortened URL. Once that's downloaded on the box, and please, if you're a red teamers, raise your hand. Yeah. If you're a red teamer in here, please use certutil for downloading stuff. It's awesome. So yeah, download files, write them to disk. Certutil is great because it actually writes it in multiple locations, so use it. So I want to read the contents of that file. That's the next command here. So we've got the get content command, reading that in, passing it out to out string, and then passing it to invoke expression. This will get past PowerShell restriction policy or execution policies if there are any that are not pushed out via GPO. And then, so once that script is loaded, I'm running a command here called get GPP password. Anybody not familiar with that? Okay. So this is a script that is useful for elevating privileges in what I'm told. I'm not a red teamer, but red teamers tell me this is one of their favorite techniques. If you've ever used group policy preferences in your environment to set local admin passwords, the local admin password is sitting out in a sysvol share somewhere. It's AES encrypted, so you'd think it would be safe. Microsoft unfortunately released the private key inadvertently and apparently can't roll it. So if you're using group policy preferences to set local admin passwords, you're vulnerable to this attack. So we run the script, we get the local admin password, and so now we're just going to do a run as and do cmd, type in the administrator password, and now I've got an admin shell on the box, and you can see that by who am I with administrator. So the next thing I need to do as an attacker is get the PowerShell agent on the box. So I'm just going to do the dumb thing here and load up Notepad and copy in PowerShell's agent launcher. So that's just a copy paste. It's a VB script in this case. There's dozens of different ways to get the launcher or stager code on the box. In this case, I'm just doing the simple VB script. And this is going to call, as you can see, a PowerShell encoded command. Save that, and now I just cscript and run launcher.vbs. And so now I've got an agent running on this box, and you can see Empire shows there's an agent reporting, so we're going to interact with that agent. Do sysinfo, you'll see we have an agent running as administrator in a PowerShell context. What if that PowerShell window closes? What if the user logs out? I need to be able to persist somehow on this box. So we're going to do a PS inject with the listener, and let's just go into Spools V process because it runs a system, it's long running, red teamers love it. And so once that new agent spins up, we'll kill the old agent. Now that PowerShell window can go away and who cares? And we'll do sysinfo again after interacting with the agent. And we'll see that now we're running a system in the Spools V process. So all the while we've had our tool running in the background here, recording the events that are happening on this machine. So now we have Spools V kick off the shell key user command. So we can see who the users are that are logged in. We're going to run Mimikatz, which is an Empire agent built in. And there's my Mimikatz output. And just for good measure, run one more shell command. We'll run netstat here. And that's the end of the attack video scenario. And now we'll let Matt take over and show the demo for what we captured.
So this is a little dangerous, giving props to something before I use it. But if no one has ever used the start demo script, I think Jeffrey Snover wrote it for basically just running different demos in PowerShell. It's pretty awesome. So it just types out commands for me, makes it look like I don't have any grammatical errors, and it lets me just continue. It's so awesome. It's so awesome. So anyway, I'm going to go ahead and import my module. We call it PSWasp, and expand all the different commands. So Dave mentioned that while we were running the attack scenario, we are also just running a single PowerShell command called get ETW forensic session, or forensic collection. And what that does is it just allows me with a single PowerShell command to spin up all those 6 providers with the keywords already enabled and writes them out to a circular buffered output ETL file, so it doesn't grow to be infinitely large. And then at the end, we just run the stop. We stop our ETW sessions, and then we run it through the get ETW forensic event log that parses the ETL files into something that then we can digest with PowerShell. The other functions here are really just designed to help you interact with ETW providers as you want to expand your research. So the first thing we'll do is we'll kind of look at some of the other ETW providers on the system. So the first command I'm going to run is just selecting the unique number of ETW providers on Dave's system. So this is 602. On more modern versions of Windows is over 1,000. So again, we're using 6. There's over 590 other ones that are untouched, and I can promise you they contain other useful information. So the WMI provider is another one that got mentioned this morning that's absolutely valuable. There's a registry provider that if you're brave enough to turn it on, it contains really good data. There's just a lot that's out there. So let's drill into one of these and figure out like what can we actually tell by looking at these providers. So the one that we use probably the most is called the kernel process provider, which again is not coming from the kernel, but contains a lot of the same information that you can get from the kernel. And so what we can see here is a couple pieces of information. So on the top, you see that there's a name and ID. And this is really either the namespace or the GUID that represents the unique identifier for this particular provider. And so these have to be unique. And in some cases, you'll see that the ID is just straight zeros, and that generally means that it's not going to be useful for you. I found that the helpful links are not very helpful, but maybe there's something else there. Otherwise, if there's different levels that you can enable, other different types of information. And then there's these keywords. So keywords are the first level of filtering that we implement in order to only turn on like events that we care about. So I'm going to enumerate the different keywords for this kernel provider. So you see that we can break it all down into process events, thread events, image load events, CPU priority, and a couple others. For what we're enabling, all we're doing is the first 3. So process, thread, and image. And then if you actually wanted to investigate what is going on, you can get more information about the specific events recorded by each provider. And so yesterday in Matt Grader's keynote, he did a really good job of explaining his thought process of when he went about, just flipping register keys to bypasses, which seemed relatively straightforward. But this is really my thought process when I started investigating different ETW providers. The first thing I did was I would enumerate tasks. And they give you just a pretty generic name about what each task and the corresponding ID or value. So the value here is the event ID that you would see in the event log, and the name is just a fairly uninteresting but somewhat descriptive name. And then Dave actually discovered that we could go even further and pull out the specific event log messages without the variables being inserted into them. So if you're starting to investigate different providers, drilling down into the specific message events that get returned, and then identifying, hey, this looks like it could be interesting, assuming that %1 evaluates into something interesting, I can really take this somewhere. And then you can go about turning on this ETW provider, running some command, stopping it, and then just parsing it with get one event, and you're on your way. That's really how I did most of this research. So now we can just enumerate, these are all the active session names. Luckily, there's nothing offensive on Dave's box here. And so here's how we can understand what's already running. There's also ways that you can enumerate details about these sessions to understand what providers are on under the hood, what settings are these providers, what keywords are there enabled. We're not going to do that right now. So now we're going to actually import the, in this case, it's what we collected during Dave's demo. So I used export CLI XML, so I'm just going to import this object in so we don't have to walk through the parsing. I mentioned it was slow. I'm not lying to you. So if we sat here and we parsed the whole thing, it would take about 2 or 3 minutes. So we're not going to do that. So now that we have our session, we can now think about, what is it that we want to start with? So Dave started with PowerShell being executed. So I'm just going to expand out my Empire session and just tell me what processes match PowerShell and give me their process ID and image name. And so we have 2 different ones. So we have 6804 and 5392. I'm going to go ahead and drill into 5392 because I know that's the first one and we don't have a ton of time. So otherwise, I could look at both of them. So I'm going to just, select all the different note properties that I can now look at with this single PowerShell process. So you have things like child processes, the command line, specific PowerShell commands, when it was created, any type of file system activity, and a bunch more. And depending on what information we're able to capture, so if we're able to grab this process start time and the stop time, you get a lot more. Or depending on what the process does, obviously it depends on what properties we're able to enumerate. So if we're going to drill into this one specifically, maybe we want to start with different PowerShell commands. So let's look at all the unique PowerShell commands that Dave ran when he ultimately started up his session. And remember, it started with get GPP password. So we see pretty much right here in the middle, get GPP password is enumerated. Okay, but what if we want to take that a step further? And what if we wanted to know, okay, that looks bad, but I can name anything, whatever. Maybe I want to look at all the script blocks that ran here and get the source code for get GPP password. So actually what we're capturing here are the full script blocks associated with each one of these commands. And now we can start enumerating other things like the child processes that were spawned when Dave was doing this. So here we see he ran whoami/all. We ran certutil with the URL cache. All of that is being captured. And then ultimately when he did his privesc, he updated with the administrator account, and then he spawned command. So we can start drilling in from here. So the first thing we're going to look at is certutil. So we're just going to match certutil and just take a look at all the different things. So, oh, Dave, you have opposite scrolling. That's why I've been having trouble. So like I said, you have the process ID, the create time, the parent PID, the session, all the different images that were loaded, file I/O, domain lookups, network connections, pretty much most of the things that I found to be relevant.
Where another place, if you didn't know, certutil is downloading another copy other than just that one file that was in the directory. It also writes it to the Internet Explorer cache, so keep using it. It's good.
Giving up all the jewels, Dave.
I know.
All right, so let's look up our domain lookup. So Dave's original command line was obviously a shortened URL, goo.gl. That expands out to... Oh, it is warm.
It is warm. Oh, you guys, thanks.
It's really warm.
It's really warm.
Oh.
maximum drinkable temperature?
I suppose.
Without burning yourself.
I just burned my tongue.
Really?
Yeah. Oh, it's the metal, too. The metal makes it worse. All right, so let's continue. So we've got our 2 domain lookups, and now we can confirm that the 2 network connections match up with the domains that were queried. And if we wanted to look up RunAs, so that was the next step in this attack, where Dave then pivoted from elevating his privileges to then spawning a command shell, ultimately as an administrator. And so here we grab everything from RunAs, including the full command line. But what's probably more important than RunAs is what was happened after that. So we're going to kind of dive into the child processes launched underneath the command prompt. So here we see command.exe, and if we keep going here, we'll see, okay, well, show me everything else that was launched under command.exe. And here you see who am I, that's what he ran to understand what his privilege level was, notepad, launcher.bbs, and then ultimately cscript.bbs. So if we look at these, so for example, if we want to take a look at notepad, and we wanted to just confirm the file IO associated when he launched notepad, we can confirm that yes, indeed, notepad was used to then ultimately create launcher.bbs. And then when cscript was run, cscript also launched launcher.bbs, and more importantly, we can see, just even looking at this in child processes, that PowerShell is an immediate child process.
I was man of waiting.
Were you?
Yeah.
Oh, that's awesome. You have a career in this.
Yeah.
So here's the second instance of PowerShell that we first saw when I ran the initial command, and it's the child process of cscript that ultimately spawned the Empire agent. And as we dive into this version of PowerShell and look at the command line, you'll see it's, pretty synonymous with just interesting looking command lines that end in base 64 encoded text. So let's take a look at what this PowerShell did when we look at the sorted commands. And so since we know, it said invoke ps inject, invoke empire, we get a list here of all the different commands that were executed. And similar to what we had before, we can now pull out the source code for the Empire agent and capture it and associate it with this PowerShell process. So all of that is now here that you can enumerate with the script blocks. So let's continue. So if we want to look at file I/O of PowerShell, there's obviously some interesting looking file I/O that could be relevant. We don't know yet. We should go take a look at these. As we continue, we're kind of at the end of the rope. So if you looked at child processes here, you'll see that conhost, which is always launched with PowerShell, is just sitting there, which is fine. But if we think back to some of the domain lookups we saw earlier with let's pop a box, we can see that when you can see that this made a domain lookout to let's pop a box. I'm getting ahead of myself. And we can confirm that it made a network connection here. And then Zach alluded to this earlier. We can also pull out, the full number of kilobytes written and transferred over the web connection. You can also do this for file I/O, which is really cool. And this is something that gets captured at process exit and is a property associated with the process stop in the kernel process provider. So it's pretty cool. So as we continue, we can say, okay, what are all the loaded images associated with PowerShell? And not only do you get the image path, but you get the offset and length in memory that it was actually loaded into. So this is interesting a little bit later, but with PowerShell, things look relatively standard. So go ahead and close that out. And now, as I mentioned before, we're kind of getting to the end of this level of analysis. But if we start pivoting around and say, well, we saw that PowerShell pinged out to let's pop a box. Maybe this means that something else did it too. Let's take a look at that. So you see that there's a second process ID here that made a similar domain lookup, and it's process 1924. So let's take a closer look at 1924 and see what it actually did. So I'm going to select image name and command line. They're both blank. So are we out of luck? Interesting thing about ETW is it only collects data that happened when you're watching it. So if it's, let's say, a process or service that starts up before you start monitoring it, you're going to be completely blind. So in this case, Dave injected into the spooler service, but since it had started before our capture, we're kind of blind here when we look at command line or image name. But if we look at file I/O, it becomes pretty clear where this thing has been writing activity to, so you can start to infer what it actually is. So we're just going to move a little bit quicker here. So we're going to look at the child processes associated with this. So we see pretty much everything that Dave ran, QUser, who am I, and ultimately netstat. And then we're going to also just confirm the domain lookup of let's pop a box. And then here are all the loaded modules. And what's interesting here is that the automation DLLs have very odd offsets in this injected process. So if we look at this, they are at very different offsets in memory and than all the legitimate loaded DLLs. So from here, we could potentially infer that this might have been injected. I don't know for sure, but it just looks suspicious. That and the automation DLL is into the spooler service. So the last thing I wanted to show you, the second to last thing I wanted to show you is the threading capability. So you can track everything not only at the process level, but also down to the individual thread for each process. So if we remember that there's a particular thread that was responsible for the domain lookup, we can actually drill into that given thread and see not only the DLL that was loaded into that thread's memory space, but then also the activity associated with that thread. So in this case, this is a thread level tracking for individual processes that allow you to track things like domain lookups, file I/O, other things that we're tracking, including the loaded image associated with this thread. And similar before, so Dave ran invoke Mimikatz. You can see that here, and then we also can get the full invoke Mimikatz script block that we logged here. And then the last thing I added this morning, just because I got confused, is that we've been traversing a lot of different parent and child processes. And I thought, man, wouldn't it be nice if we had a way to graph this out? So one of the things I did this morning and last night, so I apologize for terribly ASCII art, is basically graph out all the different processes that we can watch. So this was the injected one. We see the children there. But more importantly, you can see, where we started with PowerShell and what that looks like. So you see, start with PowerShell. We see the child processes there, all the way down. So yeah, I think we're just out of time. I know Nick's coming up next. But appreciate the time. And yeah, we'll be outside if anybody has any questions or wants to talk further. Appreciate the time.